Broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, good evening, folks. Depending on where you're logging in from, one of those will sound just about right to you. Welcome back to another great episode of our Best Practices webinar series with 7SIGNAL. I see a decent amount of you have logged in early, so thank you for doing that as always. Let us know where you're logging in from today. If you are working remotely from home, if you're in the office, what part of the world you're logging in from, we'd love to hear from you. I myself am back in our Cleveland headquarters office, and I am joined today by Chris Minton, who is joining us from Texas. How are you today, Chris?
I'm right as rain, Kelsey. Thank you. How are you guys doing?
Great to have you. And we are also joined, as always, by Jim Vada in Cincinnati. How is it in Cincinnati today, Jim?
Not bad, pretty mild in the 50s, kind of mixed clouds. Not bad, I'll take it.
I feel like I always get my weather updates from you from what it's like back home, Jim, every week. So I appreciate it.
My pleasure.
Awesome. All right, I see a couple of you dropping in. We have JJ joining us from Cape Town. Thanks for being here, JJ. We have Wayne in the office in Denver, Colorado. Thank you, Wayne. We have Germund joining us again. Thank you, Germund. Always happy to have you. We have Kenneth joining us from Denmark again. Thank you, Kenneth, for being here. And I see a couple more of you dropping in. We'll circle back with you later as we go ahead and get started. So we are 7SIGNAL, the leader in wireless experience monitoring. And as always, before we dive into today's topic, we'll give you a little background on 7SIGNAL and what our mission is. So we have a great topic here today, understanding the role that the wired network infrastructure plays in the wireless LAN design. And as I previously mentioned, we are joined by Chris Minton today, who, Chris, if I'm not mistaken, you recently earned your CWDP this past month. Is that right?
That's right. I think about 2 weeks ago, I believe.
Awesome. Well, congratulations again.
Thank you.
Great. And as I said, we also have Jim Vada, who's our Chief Wireless Officer here. And I'm Kelsey Rizzuto, the Marketing Specialist here at 7SIGNAL. Really excited to dive into this topic today and hear from you all with any questions that you have throughout the webinar. So a few announcements before we begin. We do partner with CWNP for every single one of our webinars. So if you are pursuing a certification, you're eligible for continued learning credits by attending these webinars. So if you're interested, just drop us a note and we can easily send over a PDF certificate per request. We also host a product tour every single Friday at 12 noon Eastern. So you can go ahead and register at that link there, go.7signal.com/tour. And during the webinar, I will drop this in the chat there. So if you'd like to register, you can go ahead and do so. We also send out a newsletter every other Wednesday. We just sent it out this morning, the Troubleshooter newsletter from 7SIGNAL. So if you aren't currently receiving that newsletter and would like to, go ahead and drop us a note in the chat panel as well, and we can get you signed up to receive those bi-weekly tips, articles, and survey questions. We also post our recording and slides to our Twitter account after every single broadcast. So if you're on Twitter, go ahead and give us a follow at 7SIGNAL. But if you're not, no worries. All of you who registered and are attending today will receive a follow-up email with the slides and the recording from today's topic and presentation. With that, we also post our recording to our YouTube channel, and all of our previous topics that we've covered are up there as well. So go ahead and look us up at 7SIGNAL, and you can go ahead and rewatch some previous topics that we've covered in the past. All right, so a little history on 7SIGNAL. We were established in 2007 in Helsinki, Finland, and we're now headquartered in Cleveland, Ohio. Hit a lot of major milestones along the way that we're incredibly proud of, such as the 1 billion data points that we're analyzing daily, in addition to the 5 million devices that we're monitoring daily. And with that, we also have 15 patents, which goes to show that the technology you see from us at 7SIGNAL, you're only going to see from 7SIGNAL. So to give you a little bit more background as to what makes us so different, if you look at your typical enterprise LAN infrastructure here on the right, you've got great tools, great technologies installed on the network, giving you really useful feedback and data, such as your Riverbed, Cisco, Aruba, AppNeta, and more. but we pick up where they leave off, moving into a different space, not only giving the infrastructure view, but the end user experience as well. We'll start here with Mobileye. Mobileye gives you full visibility into the user experience and can be installed on the individual devices themselves, giving you that outside-in perspective. Mobileye can be installed on any laptop, Zebra scanners, pickers and scanners, workstation on wheels, mobile phones, ultimately any mobile device to give you that perspective. And it can be installed on any Mac OS, Linux, Android, or Windows device as well. Additionally, with Mobileye, since it can be installed on the individual devices, we can give you that perspective into those external home networks as well, with a lot of us working remotely. So that's a great perspective to have, especially with work from home becoming the norm for so many of us across the world. We also have Sapphire Eye, which are the sensors for service level quality and RF visibility. And through this combination, you're really getting a holistic perspective as to what's occurring in your network that you just can't find anywhere else. All right, thanks for letting me run through our history there. Before we begin, we are going to launch a trivia question here today that Chris provided us. We'll see how you all do. All right, Chris and Jim, can you see this question? Okay, you have 20-year-old patch cables. When you move from ERP OFDM to VHT OFDM, should you be concerned? Yes or no? Okay, I see a lot of you dropping your answers in. I'll give you a couple more seconds. And we're going to go ahead and close this. All right, Chris, how did we do today?
Nice. Yeah. 84% were correct. Yep. You should be concerned.
Awesome. All right. Thank you, Chris. Thanks for answering those questions, everyone. And with that, I'm going to go ahead and pass our controls over here to Chris so we can go and dive into today's presentation.
Great. Thank you, Kelsey. Can you see my screen okay?
Yes.
Fantastic. And is my audio coming through clearly?
Yes.
Okay. So I'm a Wi-Fi guy now, so I'm always asking for clarification if you can hear me or see me. That's what we do in Wi-Fi. We send a lot of questions. Everybody, thanks for being here today. That trivia question really sets the tone for what we're going to talk about, and it's the wired network infrastructure and how it plays in the WLAN design. My name is Chris Minton. I am a sales engineer with 7SIGNAL with a NA and DP cert number right there. And let's talk about the agenda. I'm excited about this agenda, and we're going to focus on 3 topics, really. And it's like the OSI model. And you'll probably see right off the bat that we didn't include some of the common things to think about when it comes from what you need from the 802.3 world for the 802.11 world. And some of these things that we pinpoint and discuss in this conversation are very surprising, that especially in my studies and in preparing for the CWP certification that Kelsey just mentioned. And also some things were like, okay, that's common knowledge, but it's good to hear out loud. And I'm very interested in your comments and your feedback. And if you could, if I can, visualize your network, what you're involved with, and think about some of the things that maybe we missed, or maybe some things that you might think are important, or maybe not so much as important. Be really interesting to have that information on the back end of this call when we have a Q&A, and then also all the questions that you log, we actually see, so you can respond after the fact. So a lot of us in wireless are either from the data side and have moved into wireless, or are responsible for everything, or you lucky few are just Wi-Fi guys completely. And it's like the old voice days when there was voice over IP, when the data guys learning voice, and then the traditional voice guys learning data, and all trying to figure out voice over IP. It was almost like a different language. And if you have the luxury of working on all of these different environments, these infrastructure, you have a pretty good understanding. But if you've only worked in some spots, it might be very beneficial, this presentation, to see some of the things that you might not have thought of that wireless actually needs from your wired counterparts. And so we're going to do this from basically the OSI. We're going to start at layer 1, which is really just the actual wiring. And then we're going to move up the stack from switching all the way up to networking, all the way up to firewalls and all of that good stuff. And then we're going to drop back down to layer 1 again, which we talk about actual power requirements. So let's get started here. So the first thing I want to talk about in our first topic, and this is that trivia question, which is a little surprising. And when I think 20 years ago about physical cables, I'm like, well, that's a long time ago to say it out loud. But then when you think about the actual date, like, wow, that's not that old. Previous environments I've worked had really old cable. And this is a pretty interesting topic of conversation about the requirements for the cables. And especially with some of these new FIS that are coming out in later generations, and how much speed and how much data rate and even how much power they're going to be drawing. So it's a very interesting conversation. And towards the end of this PowerPoint, I have a link to a really good 7SIGNAL webinar that was done that really goes into really detail about this and some things to look for. And I just want to mention a couple of things here is that, again, we're going to be talking about the actual cable and its requirements, but also the use for Plinium rated cabling. And this might be a no-brainer for you guys. Plinium is from the HVAC days, and it's actually not from our wireless governing board. It's actually from the Building and Safety. It's actually from the national, I think it's the Fire Protection Agency, and it's actually a code because if it catches fire, you want to reduce the fact that it's going to have chemical toxins in the air. And there's a big difference in that. And I won't go into the weeds with it, but there is a great presentation I just mentioned that goes pretty well into the weeds about some of these things. And in this research, some of these cabling are a little bit stiffer. So there's some conversations about that. And one thing I did want to point to note was right here with Plinium rated APs. And why would you need a rated AP like that? And if that AP is actually going into the rafters, right? If it's going to be above the ceilings, well, it's going to fall in those categories. So those are some of the two things that we need from the wired side. And let's talk about what we need from the 802.3 environment when it comes to, I generalized it and said the network services, but again, depending on how old school you are, are you switch, route frame, right? So we're talking all of this. And I picked I mentioned 4, but if you count them all up, I think it's 6, and there's some more. And the first topic is, the dynamic host connection protocol and DNS. We're going to talk about what we need from firewall, ACL, and VLAN management. We're going to talk about the seldom thought of, but always used network time protocol. And then Radius and Ldap, what we're going to need from these guys, and we're going to hit each one first. So I mentioned quite a bit here in DHCP, but I wanted to draw the attention to DNS. And you could argue that DNS is the Achilles heel of all of this, or it is the heart of all of this. And when I say all of this, I mean all IT infrastructure. If you've ever had connection but not had connection to a DNS server, we're lucky that it's a Boolean stop, because everybody can't work. DNS is so critical to not only 802.3 devices and your endpoints, but also to obviously your stations. And DNS is thought of really as a simple protocol, and it is not. It is thought of as something that's really, you just type an IP address, bounce to a name, bada bing, bada boom, that's it. DNS has tons of options that can be set. And it is extremely valuable to the Wi-Fi side to understand how your vendors use DHCP and DNS for their, we'll call it the supplicant, or for their AP devices, or even their controller, right? There are options in DNS and DHCP like set vendor IDs that when your device, when an AP boots up, if it can get to DNS, yay. But also, it's going to be looking for a certain option string. We saw this in voice over IP networks a long time ago, but this is one of the things that is used for auto provisioning or for quick provisioning with devices. It's also very surprising how many applications are written in the code that will query DNS. Sometimes you would be like, it doesn't make a lot of sense, but it does. DNS is very critical. And it's something that sometimes just overlooked, because we always know that it's there. But again, from the wired design, I want you guys to think about, if you're in a process of maybe moving controller types or APs, looking at those data sheets and saying, how does this AP know to get to the controller? How does this AP know how to get to the cloud? The other topic in this discussion is DHCP, and I hit the basics here, right? So in your environment, are you guys mobile, right? Can somebody come and sit in an environment with hardwired in, unplug, go to a meeting, come back, right? Are those different DHCP scopes? If they're different DHCP scopes, they're also different network ranges. If there are different network ranges, that means it's a different VLAN. If it's a different VLAN, means it's a different ACL, right? So there's a lot of thought in how that DHCP lease is set up, and I can only speak to what I know, and I just know IPv4. I didn't do a lot of IPv6 and still haven't. I'm still waiting for it. I do see it's out there, but we like to make our zones in those nice little /24 siders, and that can get a little cumbersome, especially when we talk about Wi-Fi stations. And so one of the biggest issues with this is running out of IP addresses. And a lot of us in the wired in infrastructure, when we set up our DHCP server, we set all of the different zones basically to have the same timeouts, the same delays. My suggestion and a best practice that we've seen when it comes to clients, something that you might need from the wired network, is to look at the lease times, right? Does your guest VLAN need to have a 2-week reservation, right? If somebody's just going to be there for 15 minutes while they're waiting for something to happen, right? In Windows devices, it's always cached the last IP address they got on the VLAN, so it will always request that IP. But is there really any need for your guest environment to have not just such a big cider? A lot of customers like to have that because you never know how many guests are coming in, but maybe shorten the lease times, right? Something you might need from the wired environment. Same, completely different from the access. Your access devices are usually your corporate, your infrastructure devices, your client that are always there. The trusted environments, you're going to want those lease pools and those times to be different than a guest. And then also I mentioned as another example, the voice over Wi-Fi devices. So these devices, if they haven't, they're usually on their own SSID, which means they're on their own VLAN, which means they have their own scope. If they're not, that's something that, as a best practice, especially when it comes into authentication, especially when it comes into roaming, that's something we can talk about here in a little bit more detail. But in this presentation, I listed the options here for just one part of the DHCP process and one part for the DNS. And it really is fascinating what you can accomplish by using all the different options that are set in DNS. And you'd be very surprised, just like I am, about how the vendors actually use this to go about your day, and how you need to have that set up in your environment. So let's move up we're moving up the stack. I guess we're moving up the stack. Let's talk about ACLs, firewalls, and VLANs real quickly. So it is a no-brainer that if your wireless controller type is different, you're probably going to need different firewall access lists, right? If you've got a controller-based Wi-Fi and you're in a secure environment and that's your inside, probably not a lot of stuff going out through DMZs or the internet. If you're cloud-based, again, that's a different story. You're going to have to open up those ports. That's something you're going to need from the wired infrastructure. it won't, well, it shouldn't tax your firewall. Your firewall should be able to handle a stateful transfer like that. But it's something to look at, and especially with a lot of IPS, IDS, we're talking about with WIPs, and then also a lot of monitoring, a lot of reporting. Even east to west traffic or north to south, you might want to keep an eye on that to see how much data is actually going through. And we're not going to talk about bandwidth, upgrades until like the very end. But it's always a question being asked and something to look at. And the one that gets me all the time, besides layer one, I always forget to plug something in. That has been my crux. But in VLAN management, setting the right VLAN. And again, rule of thumb, you shouldn't have user traffic on VLAN 1, right? It should be management. And also, depending on how your controller is set up, right? If you're using a centralized wireless LAN controller, or if you're having APs, like using cloud, right? We're doing split split MAC type assignments. It's going to be a little bit different on who does what with trunking. So it's something that from the wired world you want to keep an eye on. And again, I address again the voice Wi-Fi WLANs as well, just because there might be some things that we need to add there as well. So network time protocol, very underlooked. A great test case for you guys if you're have some time, feel free to run your Wireshark on your machine and take your time zone if Windows or Mac off of automatic settings, and then set it back on again, and then do a Wireshark search for NTP. It just shows a ton of communication going back and forth trying to get that aligned. And again, there is secure NTP. You've got your local. You can make your own. To me, as a best practice, it doesn't matter how you do it. It's just it matters that your devices are showing the same time. And that's especially apparent in 802.11 stations when the 802.3 are off. You can see very heavy sync issues all the way up the stack when the devices are not in sync, right? Also, authentication becomes a very big problem. If your Wi-Fi stations are not set to NTP, or they are quite a bit off, and to the supplicant or to the radius device, you're going to have authentication issues, even based on time or even security measures will kick in. And then obviously troubleshooting is almost next to impossible if your times are completely off. If you're troubleshooting from say a client server type application, it's really good to have that NTP connectivity and those things aligned, right? So that's what we're looking at from the network services example. So let's move on to radius and Ldap. So from the wired environment, and we're talking about what we need from the wireless, we need the same thing as somebody that's hard-coded in wireless or in wired. Again, you'll see a theme with me with a voice Wi-Fi device. Sometimes, especially when it comes to roaming, with PEEP and EAT, with the authentication process, some of these devices might cause a bit of consternation. I did want to go back to an example with NTP. It just reminded me, so forgive me for skipping ahead. I have seen this as really pop up in my career in warehouses and in hospitals and manufacturing, where a device or handheld, a picker that has a very long life cycle, a rugged device, an IoT type device that uses Wi-Fi, has a 7-year lifespan, has been used for 12 years. Don't laugh, because they're, we all have them. They get forgotten, and sometimes they can get really off on their time, and it doesn't show a Boolean type fault. It starts to show really weird application behavior. And one of the easiest things to check is to locate the time. Working with a customer a while back that they had their devices that were it was about 2 years off right? Just something happened where it just stopped doing total time and then it just moved into it. So it's one of the easiest things to check is to make sure just to check the local time. Save a lot of headaches. But back to radius. Again, with roaming and moving around with the Zebra type device or a Wi-Fi enabled device or something from healthcare, where that radius device is physically and latent and from latent distance could really affect the actual device performance and the application, of course, that is above it. And it's really difficult sometimes to tell. So it's really good to have some good understanding of what your radius environment is. And again, based on how you set up radius, a local 2080 or 80/20 rule, you're going to have to poke holes through firewalls, ACLs, what have you. But again, we have noticed, especially in my career at 7SIGNAL, that, and this is what we're looking at all the different clients, how it went through radius on one BSSID at a certain point in time. It makes a big difference sometimes on how everything else starts to cascade of looking at that key performance of how the radius is and timing really could make a big difference for your Wi-Fi stations using the backbone wired infrastructure. So that was a mouthful. Let's go to our last topic, and let's talk about the actual back to layer one, and let's talk about everybody's favorite, power, right? So when we talk about power, though, we're talking about from the switch port, right? From the client switch, right? The access layer switch, the PoE switch. The PoE switch is really turning into a powerhouse, and there are quite a bit of devices that aren't even Wi-Fi that that will draw from this device. Obviously, VoIP phones, wired security cameras, and then there's wireless, and then there's wireless APs, right, that are connecting into it and drawing power. I wanted to mention that on the data sheets for every product, they usually will say maximum power consumption. And that is kind of like a theoretical, like this device, if it needed to, at its most, will draw this much power. You can use that into your estimates if you're looking at planning or upgrading managed switches, especially enterprise class switches. The CLI commands and the UI they've done a really great job over years of showing you what your power budget is. What's really interesting is I'll give an example about Wi-Fi access points, about how much power they draw based on the radios. At another career several years ago, I was working for a Wi-Fi vendor, and we came out with one of the first triple radio access points, and it did WIPs overlay, and it did access 2.4 and 5 radio, and it was new at that time. And these two power standards were just coming. The new power standard was coming, but what we found is that the device, when using AF, it wouldn't power all the way. It wouldn't work 100%. So product development had a choice. Do we turn off WIPs or do we turn off access, right? And then how do we communicate that? And do we communicate that with basically an asterisk? So you look at a product sheet, which again goes back to the spec sheets. It says that this device can be powered by 802.3.AF, asterisk, right? But you need more power to get this whole thing working. So having all of those different type of devices, and then knowing your budget and your concurrent clients really factor into the draw. And we mentioned earlier and through the presentation about a really great practice, or a great best practice web series that was done. It was called PoE and the Future of AP. And I have the hyperlink there. It's on our YouTube channel for 7SIGNAL, but it really goes into the weeds of what to look for, right? And goes really into some of the newer power standards and the challenges that's going to that's gonna become of it. So in summary, I mentioned basically three topics which you could look at from a wired perspective. The actual cabling, all the way to the type of cabling that you need, especially coming down the line. We looked at some of the network services that you need from the 802.3 world, right? And some of them that you just is a given, like DNS and DHCP and NTP, but Wi-Fi really needs these three services. I could argue, sometimes more critical than our wired counterparts, right? Everything that we do is in microseconds or nanoseconds, right? And having these connections and knowing how DHCP and DNS and NTP work, and then how our supplicants, our APs, use this information just to even boot up, just to do their day-to-day based on the controller environment, is really powerful. And then knowing if you don't have visibility or access, that's another team that's in charge of DHCP, DNS, just posing the question, how do we have our DNS and DHCP set up? Right? Is there things that we can do? My device that I'm looking at, I'm actually going to need this option turned on, right? And if we might have to do some movement with it. That's a very difficult one to troubleshoot after the fact, as I'm sure some of you guys are aware of. And then talking about the radius authentication, ACLs and VLANs. That information is always, you're always going to need, obviously, that from the wired environment. We didn't get into a conversation about, bandwidth requirements. Do we need to upgrade the pipe? Do we need to upgrade the core, backbone to the access switch for the new FIS standards? Do we need to, you can go down a path of saying, maybe I need, quite a bit more from my wired infrastructure because of these, future coming. My thoughts are, don't get caught up in that trap. I believe that, 1 gig at the AP is great, and should be great for quite a while. It's just that there are some things that you need from the wired side to help your Wi-Fi, actually behave, and then also understand, how the Wi-Fi environment actually, goes and uses its backbone to get out and have your customers for a great experience. So I like to pause for a second, if Jim, if there was anything you wanted to add, and then I was going to move to Q&A.
Yeah, nice job, Chris. And the only thing I'd add is, fairly soon for Wi-Fi 6E to support 6 gigahertz radios, that will have 3 802.11ax radios that are all hungry for power. I think it won't be long, but and maybe even that first generation of Wi-Fi 6E access points will require 802.3 BT, so the next generation of PoE, and that, of course, has a cascading effect on the switches that you're running and the power that they require, just from the mains power in your building, and then that has an effect on UPS sizing for battery backups and so on and so forth. So keep that in mind, and also check out the Devin Aiken webinar that Chris mentioned, because he goes deep on some of those forward-looking issues that are coming around the corner pretty fast.
Jim, could you imagine going to your boss and saying, "Hey, I'm going to upgrade my Wi-Fi APs," and they'd be like, "Great." It's like, I need new UPS batteries." Like, how do we go from there to there? Like,
I need 30 amp circuits in every IDF now. It can really cascade and turn into a much larger project than maybe anticipated at first.
Mm-hmm.
So some good questions in here so far, Chris. Should we jump into some of those?
Yeah, absolutely. I'm gonna go ahead and stop sharing my screen. And yeah, so I'm gonna absolutely.
Yeah, let me just bounce some of these off you, and I'll jump in here too. Good comment here from Anders. He says, always be careful about not using those thin Cat6 6A patch cables when cabling for APs or other equipment that's using more than 15 watts of PoE. Yeah, good comment. Those can certainly, lead to problems if you're powering a device using a cable that's not a heavy enough gauge. Can lead to heat buildup and all sorts of issues. And that can get even worse if those cables are bundled together. Could potentially be a fire hazard, actually. So good point there, Anders. Comment from a friend of 7SIGNAL, Germund. Thanks for joining us, Germund. But he says MS Teams has a strong need for good DNS service. So, and of course we know, Chris, that if there's a problem with your collaboration tool, that Wi-Fi is usually the first thing that gets blamed.
The very first. You're absolutely right.
Even though, you know what, as the old saying goes, it's always DNS.
Oh.
And maybe one last question from Wayne. He says, how long will Cat5e be good enough? How long will Cat6 be good enough? Any thoughts there, Chris?
That's a great question. Yeah, that's. I think that goes back to your point about Wi-Fi 6E, right? When that starts to become, that's one of those conversations we have. For right now, I think it's good enough, right? Jim, what say you?
Yeah, a couple thoughts there. If I was doing new construction, I wouldn't use Cat5e. I'd probably look at Cat6 or Cat6A.
Mm-hmm.
But if you have Cat5e, you can use multi-gig Ethernet protocols on it and get up to 5 gigabits per second of throughput. Maybe not at the same distance as Cat6. So there's still some life in those cables. What the lifespan of Cat6 will be, wow, that's hard to say.
That is hard to say.
Yeah, I don't see I don't see an end on the horizon for Cat6 anytime soon. But if anything, it really starts pushing it. It might be electrical requirements for PoE, perhaps more than the need to support Ethernet speeds greater than 10 gigabits per second. Because even now, 1 gigabit per second is usually plenty for 99% of the time. And having the ability to go to 10, that's a lot of future proofing there. So those are my thoughts.
Yeah, that reminds me of an interesting thing about going back to doing the lag for Cat5e to get to that speed. When you do that onto the switch port, it's the switch port, the backplane is really just controlled by certain asyncs. So sometimes, according to your documentation, you can only do so many lags, so many aggregations on a switch port, and you actually have to move your actual physical connection. So your other asyncs that control that backplane, which I ran into in my data center days, because you can actually run out. So that's another idea of conversation, saying, well, I can stay with this cabling, but then I'm going to have to, do I now have to buy, all new switches, because I can't, lag as many as I, could. So that's, one of those, Jim, you talked about, you start to cascade, right?
Yeah, it makes the project grow exponentially sometimes to get those high speed and support the, PoE needs. Cool. I think that about wraps it up, Kelsey.
All right, that's all we have time for today. Thank you for everyone for being here, giving us 39 minutes out of your workday to dive into this topic. And thank you, Chris and Jim, for walking us through this and answering those questions. Always happy to hear from you all. And with that, we hope to see you at next week's webinar. So have a great rest of your day, everyone. Thanks, Jim. Thanks, Chris.
Thank you, everyone.
Bye, everyone.
Thank you,
Thanks,
guys.
Chris.
Bye.
See you, Kelsey.